Hi everyone. For today, we will be discussing one important applications of differential equations, which is the applications to electric networks or electric circuits. In a simple RL or RC circuit, a circuit composed of a voltage source, a resistor, and an inductor, or a voltage source, a resistor, and a capacitor. So we have an electromotive force, which we're going to call as Vs, a resistor, inductor, or capacitor. It comes from Kirchhoff's voltage law that the summation of voltage drop is equal to the electromotive force. So we can say that VR plus VL equal to E, or we can also say that VR plus VC is equal to E. As an introductory course in electric circuits applying the notion of differential equations, we can now go directly to the differential equation model. We can have it as L di over dt, which is the voltage in the inductor, plus IR is equal to E. So where I is the current, which is the flow of electrons, R is the resistance, E, which is the supply voltage, is the electromotive force, and L is the inductance. Now, for capacitors, the model would be 1 over CQ plus IR equal to E. So we use charge. The voltage in the capacitor is equal to Q over C, which is equal to the integral of I dt. So we can represent everything in terms of Q. So R, taking note that the current is dq over dt, so we can have it as R dq over dt plus 1 over CQ equal to E. So for some of the unit checks, V is in volts, I is in amperes. Sorry, wrong spelling. Amperes. R is in ohms. L is in henries. And C is in farad. Q is in coulombs. Let's try to apply that for this some problems. A 30-volt electromotive force is applied to an RL series circuit in which the inductance is 0.1 Henry and the resistance is 50 ohms. Find the current I of t if I of 0 is equal to 0 and determine the current as t approach infinity. So we have an RL series circuit, and when we are given with an RL series circuit, the model that we will be using is L di over dt plus R I equal to E. We are given with some initial conditions. The electromotive force is 30. The inductance is 0.1 Henry. The resistance is 50 ohms. And I of 0 is 0. Let's plug it in. Plugging it in on the equation, so we have L 0.1 di over dt plus R. Your R is 50, I equal to E, which is 30. We can multiply this by 10, so we will be having di over dt plus 500I equal to 300. We can solve this using Laplace transforms. So the Laplace transform of I prime is S, I of S minus I of 0 plus 500 I of S equal to 300 over S. I of 0 is 0 from this condition. So we have I of S is equal to 300 over S plus 500 times S. This can be decomposed into a partial fraction with the denominator S plus 500 and S. When S is equal to negative 500, the numerator can be derived as negative 3 over 5. It would be 300 over negative 500. And when S is set to 0, so when we set S to be equal to 0, we will be having 300 over 500. So that is 3 over 5. So we can now have I of t to be equal to negative 3 over 5 e to the negative of 500t plus 3 over 5. So this is the current at any time t in terms of amperes. So I of t can also be written as 3 over 5 times 1 minus e to the negative 500t amperes. We are also going to determine the current as t approach infinity. So as t approach infinity, this term here would be 1 over e raised to infinity. So it would be approaching 0. So we can have I of infinity is the limit as t approach infinity of 3 over 5 times 1 minus e to the negative 500t, for which this approaches 0. So we have I of infinity is approaching 0.6 amperes. For the second part, a 100-volt electromotive force is applied to an RC series circuit in which the resistance is 200 ohms and the capacitance is 10 to the negative 4 farad. Find the charge Q of t on the capacitor if Q of 0 is equal to 0. Also find I of t. So we're going to use the equation for um, the simple RC circuit. So R dq over dt plus 1 over cq equal to E. So the equation is R dq over dt plus 1 over cq equal to E. We are given with the electromotive force E equal to 100 volt. The resistance is 200 ohms and the capacitance is 10 to the negative 4 farad. We're looking for the charge Q of t on the capacitor given that Q of 0 is 0. Let us plug in 200 and we have dq over dt plus 1 over 10 to the negative 4. 1 to the 10 to the negative 4. So that would be 10 to the negative 4q equal to E, which is 100. So 1 over 10 to the negative 4 is 10 to the 4th. So we divide everything by 200. So we divide this by 200, this one by 200, and this one as well by 200. So we have dq over dt plus, so we have 50q equal to 1/2. So with this, we can have s q of s minus q of 0, where q of 0 is 0, plus 50 q of s equal to 1 over 2s. So for q of s, it would be 1 over 2s times s plus 50. So this would be a fraction 1/2 of s times s plus 50. So we can have our q of s to be a fraction with the denominator s and s plus 50. When s is 0, we have 1/2 divided by 50, so 1 over 100. When s is equal to negative 50, so we have 1/2 divided by negative 50, so we have 1 over 100. With this, we can compute for q of t. So that would be 1 over 100 minus 1 over 100 e to the negative 50t. So this is the charge at the capacitor at any time t. So the unit is in coulombs. We are also asked to solve for the current. So for I of t, it would be the derivative of q with respect to t. So it would be 0 minus 1 over 100 times negative 50 e to the negative 50t. So our I of t is equal to 1/2 e to the negative 50t. The unit is in amperes. For the last item, a capacitor C in series with a resistor R is charged from a source. Find the voltage V of t in the capacitor, assuming that at t is equal to 0, the capacitor is completely uncharged. So R dq over dt plus 1 over cq is equal to E. So we have R is equal to 200 dq over dt plus 1 over 0.2 q is equal to E, 24. We divide everything by 200. So we have dq over dt plus, so this would be 1 over 0.2 divided by 200. So that would be 0.025 q equal to 24 over 200. So we are given with C of 0.2, R of 200, and E of 24. Take note that 24 divided by 200 is 0.12. So here, we can simplify this as S, Q of S minus Q of 0 plus 0.025 Q of S equal to 0.12 over S. We just have taken the Laplace transform of the equation, taking note that the initial charge is 0 because it is completely uncharged. So our Q of S, we multiply it by S times S plus 0.025 would now be equal to 0.12 over S times S plus 0.025. With that, we can have our partial fraction equivalent. So our Q of S would be something over S plus over S plus 0.025. So we have 0.12 over when S is 0, so we have 0.12 over 0.025. When S is equal to negative 0.025, so we have 0.12 over negative 0.025. So our Q of t would now be -4.8 e to the negative 0.025 t. So this is the charge at any time t. So the unit is in coulombs. The voltage in a capacitor is Q over C because the charge is CV. So we are also using this. The charge or the voltage in a capacitor is 1 over CQ. So we divide the charge that we have computed by C. So the voltage in the capacitor is 4.8 times 1 minus e to the negative 0.025 t, and we divide this by C by 0.2. So we will be having VC equal to 24 times 1 minus e to the negative 0.025 t. So the unit is in volts. And that is the voltage in the capacitor at any time t.